Hey, what's up? Welcome to this new video. This one is paper 1-2 of May, June 2021 for Add Math paper 1-2. Okay, so with that being said, let's move on to questions number 1. So here, what do we have? So here we have what? We have to write this thing in the form of this, where A, B, C are constants. So pretty easy, step by step. Let's first expand the brackets. On top you will have P power minus 2, Q power minus 2 times R power minus 2. And then here we have R power 1/3. Now divide by, here we have P power minus 2, R power minus 1, and Q power 3. Now, obviously we can simplify this by the laws of logarithms. For example, let's say you had x power A multiplied by x power B. That will be simply x A plus B. If you had x power A divided by x power B, that will be simply x A, because we have divide will be minus B. So these are the laws of medices we have to use in this question. So step by step. So let's regroup all the same term or same base together. So here we have P. So P, we have P minus 2. And we only have this one, P power minus 2. Okay, and then here we have Q minus 2. And then we have only this one, Q power 3. And then we have R minus 2 times 1/3 divided by R minus 1. So simplify. For the first one, that will be what? So P power minus 2, divide is minus, here we have minus 2, multiply by Q minus 2, here we have divide will be minus 3, here we have R minus 2, here we have a multiply will be plus 1/3, and here we have divide will be minus, and here we have minus 1 will be this. So now we just have to simplify every single term step by step. So here we have minus 2 plus 2 will be 0, so P power 0. Q will be minus 2 minus 3 will be minus 5, and R will be what? So let's use our calculator here so we don't make any silly mistakes. Minus 2 plus 1/3 plus 1, that will be minus 2/3. So as you can see, A, B, C are constant. So A is 0, B is minus 5, and C is minus 2/3. And that will be your question number 1. Now let's move on to question number 2. On the axis below, we have to sketch the graph of this. Sketch, again, it is not draw. Sketch, it can be done approximately. Now, stating the intercepts with the coordinate axis. So pretty easy. The first thing I like to do is I like to first assume we don't have any modulus. For example, let's say let y become 4 minus 3x. Right. Of course, you'll be drawing with a pencil, so you can erase if you make any mistakes or not. So first thing first, on the y-axis, on the intercepts on the y-axis, we know the value of x will be 0. So what is the value of y? Y will be 4 minus 0 will be 4. That will be the point on the y-axis. Now on the x-axis, let's continue here. What do you know? The value of y will be 0. So we place back in here, you will have 0. That will be 4 minus 3x. 3x will be 4. So finally, x will be 4/3. Okay, that will be the point on the x-axis. Now we can kind of sketch them. Let me draw my scale approximately. So let me have 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. And here as well. So 1 minus 2. So because you have the point 0, 4, let me have this as 2 and this as 4. This is my first point. And this point will be 4/3 is what? 4 divided by 3 will be 1.33 something. So let's have 1 here, 2 here, 3, and so on. So 1.3 something will be what? 1.3 something will be somewhere over here. Let's check. That will be approximately, so 1.2, 1.3, somewhere over here. Right, so that's the other points on the x-axis. So we have to show this is the value 4/3. Now obviously we have to first draw the line. It is a straight line obviously at first. So here we have these two joining together. But now we have to understand for this is the graph without the modulus. What does it mean to have a modulus? So pretty easy. Modulus means any value that goes below will be reflected upwards. For example, usually for the line without modulus, you will have this part as well. Now you have to be able to take this one, reflect on top for the modulus sign. So let's see what point we can have here. So let's say, let's take 3. 3 will be what? 3 when x is 3, what is the value of y? So that will be 4 minus 3 times 3 minus 5. So 5 will be somewhere over here as the modulus value. This is 4, 5 will be over here. 1, 2, 5 will be over here. So this join with this. Okay, so since you'll be drawing this with a pencil, obviously you will erase the part that is below, because for modulus it means every value have to be positive. We cannot have values below the x-axis. So finally you have to label this as y equal to 4 minus 3x. Okay, that is only 2 marks, not too bad. That is question part A. Now for part B, we have to solve the equation. Here we have modulus of 4 minus 3x is more than 7. So there's many ways to solve this. I guess one of the ways we can just try to, obviously try to square both sides. Let's see what happens. So you will have 49, that will be 16, minus 2 times 4 times 3 will be 24x, plus 9x squared. Again, this is not the only way of doing this. We can always use a simpler method, but again, I'm just trying to be consistent with what I do so you guys know exactly what to do as well whenever we have these questions. So let's rearrange. Let's send everything to one side. You will have 9x squared minus 24x. Here we have 16 minus 49, that should be minus 33. More than 0. We can divide by 3 everywhere. You will have 3x squared minus 8x minus 11 more than 0. Now we can try to find the critical values. That will be 3x squared minus 8x minus 11 equal to 0. Now we can try to factorize, obviously. That will be 3x and x. 11 will be 1 times 11. We need to have minus 8. That will be minus 11 plus 3 to have minus 8. So x will be 11 over 3. X will be the value of minus 1. So again, we have to draw the line here, or the graph, to help us find the values. The first one here is minus 1, and that will be 11 over 3. So here we have to see it is positive, so it will be in the shape of this, right? And we need the values to be more than 0. That will be this part and this part. So the answer will be x have to be less or equal to minus 1, or x have to be more equal to 11 over 3. Less than this or more equal to this. So that will be the set of values of x for which that is possible. So this is your answer for this question. Again, this is one of the ways of doing this. Or otherwise, easier, you can just, for example, whenever you have, for example, let's say we had x here, more equal to 7. That could be simply written as x less minus 7, or x would be more than 7. That is the other way of solving this question, and that should give you the same value as well. Okay, and that will be your question number 2. So that will be moving on to part 3. It seems to be a vector question. So the diagram shows the quad OABC. So we have OABC, such that OA is A, okay, OB is B, OC is C. Now, the lines OB and AC intersect at the point P, right here. Now the ratio of AP and PC are 3 to 2. So this is 3 to 2, their ratio, right? The whole thing will be 5. 3 plus 2 will be 5, the whole thing, right? If that makes sense. Now part 1, we have to find OP in terms of A and C. So where's OP? OP. From O going to P, that will be what? So step by step, we can first think about how about we just first find AC. For example, let's first find AC. So AC, that will be what? According to the diagram, AC will be A going to O plus O going to C, right? A going to O going to C to get AC. So A going to O will be minus A, O going to C will be C. Now, how would you find the value of OP? So by observation again, OP will be what? Will be O going to A and A going to P. Now O going to A pretty easy. We had C is A. Now AP, we have to use this ratio. It is 3 over 5 of AC. Right? So A is A, 3 over 5 is 3 over 5. AC is minus A plus C. Simplify. So A minus this will be 2 over 5A plus 3 over 5C. That will be OP in terms of A and C. Now for part B, given also that the ratio of OP and PB, where's OP? OP and PB is 2, this is 2 to 3 again. Same ratio as AP, PC. Now we have to show that 2B is equal to 3C plus 2A. Now we have to show this 2B is equal to 3C plus 2A. So let's see what is the ratio, or how can we use that ratio, right? So ratio of OP divided by PB is equal to 2 over 3. Now adding these two will be 5 obviously, so together here will be 5, the whole thing. So what can I write also? For example, I can write OP is 2 over 5 OB. So let's see how can we use that to solve this, right? For example, so let's do this. So we can also write OP is equal to 2 over 5 OB according to the diagram. Now OP was found to be 2 over 5 A plus 3 over 5 C. That'll be 2 over 5 OB will be the value of B. Now we can multiply everyone by 5 because we want to cancel out the base. Let's see what happens. You will have 2A plus 3C equal to 2B. So 2B will be 3C plus 2A. This is shown as required. So the only thing we have to do here is we have to understand, hey, these are the given values, right? We can rewrite this as this one because we can see they are collinear points. So we could say OP is a multiple of OB, and then we can solve to find that answer. Now I'll be your question number 3. Now for part 4, we have a curve is such that d2y by dx2 is given to you by this equation. The curve has a gradient of 4. Now we have to understand what is the gradient of a curve. It is simply dy by dx. Have to be the value of 4 at this point where x is equal to the value of 2, y is equal to 6.2. Now we have to find the equation of the curve, which means we have to find the value of y. So step by step, let's first begin with trying to find d2, so dy by dx. That will be integration of d2y by dx2 respect to dx. So first thing first, we have to do what? We have to increase the power by 1. That will be 2 over 3 divided by 2 over 3. And now of course divide by d by dx of the value inside. That will be the value of 3. And plus c as the constant of integration. So let's simplify. That will give you 3x plus 2, 2 over 3 over 2 plus c. That is dy by dx. So now we have to find the value of c by using the given values. You can see here, dy by dx was given to you by the value of 4 when x was 2. Just replace back in your equation. So that will be 4 here. Here we have 3 times 2 plus 2 over 2 over 3 plus c. Let's see what happens. 3 times 2 plus 2 power 2 over 3 divided by 2. That should be 2. So this will be 4, 2 plus c. So finally, c will be the value of 2. So here we have dy by dx is equal to half 3x plus 2, 2 over 3 plus the value of 2. Now from here we can use that to find the value of y, which is the equation of the curve. So finally, y is integration of dy by dx will be half 3x plus 2, 2 over 3 plus 2 respect to dx. That will be half is a multiple, that will be outside. Then we increase the power by 1, obviously, that will be 5 over 3. Then divide by the power, and then divide by the d by dx of this value, that will be 3. And then plus, this will become 2x, and plus d for the constant of integration. So we use c already, let's use d now. So now we have to simplify, obviously, that will be cancelled out. So you will have y. This is y is equal to half 3x plus 2, 5 over 3. And here we have 5, don't forget, right? Plus 2x plus d. Now we have to find the value of this constant d. So we have to use the given values. We have a passing point given to us as 2 and 6.2. This is the x value and this is the y value. Replace back in your equation. Here you will have 6.2. Here you have 1 over 10, right? And that will be 3 times 2, 2, 5 over 3, 2 plus d. So 3 times 2 plus 2 power 5 divided by 3, that should be 32. So 32 over 10 plus 4 plus d have to be 6.2. So d will be what? So that will be 6.2 minus 4 minus 32 divided by 10, that should be minus 1. So finally we have the value of d. We can replace back in the value of y to find the equation of your curve. That is 1 over 10, 3x plus 2, 5 over 3 plus 2x minus 1. There you go. And that is your equation of your curve for question number 4. Now let's move on to question number 5. So, given that we have this equation right here is equal to this, find the value of p. So we have to simplify, right, one by one. So from what we can see here, we have the same base. So let's send everything, so let's send these one to this side. Let's see what happens. So here we have log of a, that will be log a 20 plus log a of 4 minus log a of 5. That will be what? Because we have the same base, we can combine them together. That will be plus become multiply. That will be 80. D minus become divided by 5. That will become log a of 80 divided by 5. That should be 16. So by comparing, as you can see, because we have the same base here, the inside value here will be 16. So from this, p will be 16. That is part A of your question. Now we have to solve this equation, solving for the value of x. So step by step, how can you break this down? So we understand that 2x plus 1 is the same thing as 2x times 3 power 1. Okay, and also this is the same thing as 3 times 3x power 2. Right. Now one thing we can do here is to help us out, let's use substitution. So we can say let u equal to 3 power x. Here you will have 3 u squared plus 8 u minus 3 is 0. Now we can factorize, obviously. That will be 3u times u, 3 times 1. To get plus 8 we have to have plus 9 minus 1. So u will be 1 over 3 and u will be minus 3. So let's replace 3x will be 1 over 3, and 3x will be minus 3. So let's see how you're going to solve this question. So for this one, pretty easy. We can rewrite this as what? 1 over 3. Same thing as 3 power minus 1. That will be this is equal to 3 power minus 1. Because they have the same base, they will cancel out. So x will be the value of minus 1. Now for this one, it is minus here. Now obviously we can check. Let's use log to solve this. So we have log of 3. X will be here. That will be log of minus 3. So that would not be possible because log cannot take negative value. That will be invalid option. So only answer will be this one. X will be the value of minus 1. That will be part B of your question. Now for part C, we have to solve this equation, basically finding the value of y. So step by step, let's see what can we do. So here we have base of y. Here we have base of 2. So one thing we have to do here is change the base, make them become the same. We can choose if you want them to become the base of 2 or the base of y. For example, let's see what can we do here. Let's say for this one, what if I change, let's say change this one, it's easier. It's the same thing actually. We have log base of y 2. We can write log base of 2 over log base of 2y. So this could become this. We have to know this law to solve this question. Replace that is 4. 4 is 4. Here we have log base of 2 is 1. That will be 1 over the value of log base of 2y. And that will be plus log base of 2y. That will be your value of 4. Now to help ourselves, we can use a bit of substitution to just help us solve this question. So let u equal to log base of 2y. So that will be 4 over u plus u equal to 4. Now to cancel out this value here, we have to multiply by u everywhere. That will be 4 plus u squared. That will be 4u. So u squared minus 4u plus 4 have to be 0. Solve by factorization. That will be u times u. 4 is 2 times 2. We have to have minus 4. That will be minus 2 minus 2. So obviously u will be the value of 2. But now again, we're not trying to find u, we're trying to find the value of y. So u is this one, log base of 2y have to be the value of 2. So y will be 2 power 2. So that will be the value of 4. So to find y, we have to send this one over here. We get this one. So finally, y will be the value of 4 for your question, part C. And that is your question number 5. Again, the most important thing here is this one. We have to know how to break down the logs to make them have the same base. The idea is pretty simple. For example, let's say you have a log of x. Here we have a. We want to change this for the log of a. For the log of base a, we can rewrite this as log of base a and a on top. That will be log of base a, and that will be x. So any log can be written as in a different base by using this method. Okay, that will be part 5 of your question. Now let's move on to question number 6. So here we do not have to use a calculator. However, it means we have to show all the steps of your work. You can always use a calculator just to kind of check your answer, obviously, but you have to show the steps of your work. That's the main idea behind these questions. A curve of equation y equal to this. Okay, fair enough. Part 1. We have to find the x value of the stationary point on the curve, giving your answer in this form. So pretty easy. We know that at the stationary point, what happens? dy by dx have to be 0. So we first have to find dy by dx. So here we have y. So dy by dx will be what? We can first multiply by the power. That should be this. And then we have to minus 1 to the power, obviously. And then we have what here? Here we have minus 8 root 5. X will go away, and this will become 0. Right, if that makes sense. Now, this is dy by dx. We have to equate to 0 at the stationary point. You have this. We have to make x become subject. So we will have here. We will have what? We will have divide by 2 everywhere because we have even number here, even number here. That will go away. 3 plus root 5. That will be x is equal to 4 root 5. So here x will be 4 root 5 divided by 3 plus root 5. Now this is the value of x, obviously, but we have to express this in the form of this. So we have to simplify. We have to multiply by the conjugate of the base, and both on the top on the base. Again, this is just a way to simplify this function or this expression to find this. This is the answer, obviously, but the question is asking you to change that into that. So one way of simplifying is to multiply the conjugate to the base and top as well. Now, why we multiply both sides is because we don't want to change the expression. That's why we have to multiply on both sides. Okay, so step by step, that will become 4 root 5, 3 minus root 5, and that will be 3 plus root 5, 3 minus root 5, 12 root 5 minus 4 times 5. That will be 9 minus 5, right? Because this is the difference of squares. Remember, when we have a plus b times a minus b, we know that is simply a square minus b square. Same here, a plus b, a minus b, that will be a square minus b square. So a square is 9 minus b square is 5. That will be 12 root 5 minus 20 divided by the value of 4. Simplify, that will become 3 root 5 minus 5. So let's rewrite this down as required. We have minus 5 plus 3 root 5. This is your value of a, this is your value of b according to the question, and these are integer values which are whole numbers. This is shown as required for part A of your question. Now let's move on. So the question is asking you to hence find the y coordinate of the stationary point, giving you answer in the form of this. Okay, so step by step. So we have seen x is given to you by minus 5 plus 3 root 5. And y, which is the equation of the curve, is given to you by 3 plus root 5 x squared minus 8 root 5 x plus 60. So the main idea here is we just have to replace x in this and simplify one by one. So what is x squared? X squared will be minus 5 plus this square, that will be 25 minus that should be 30 plus 9 times 5. That will be 25 plus 45, right? That will be 70. That is x squared. So that will be this one. So we have to replace. So now y will become 3 plus root 5 times 70 minus 30 root 5. Now minus 8 root 5 times x, x is minus 5 plus 3 root 5 and plus 60. Let's continue here. We have more space. So step by step, 3 times this will be 2010 minus 90 root 5. That should be plus 70 root 5 and minus 30 times 5. That'll be this one. Now this one plus 40 root 5 minus 24 times 5 and plus 60. Because root 5 times root 5 is just 5, right? Now again, we just have to expand this, you will get this. Now step by step we have to simplify. So let's see what happens here. So here we have all the terms of root 5. This one, and this one. That'll be minus 90 plus 70 plus 40. That will be 20. So it's supposed to be 20 root 5. Now this one will be 210 minus 30 times 5 minus 24 times 5 plus 60. That will be 0. So 0 plus 20 plus 20 root 5. Your answer will be 20 root 5, where this is your value of c. C will be 20 according to the question. And that will be part B of your question number 6, sorry. Now let's move on to question number 7. So here we have a 6-character password. This is to be made from the following 8 characters. So we have 8 characters to choose from, and we need a 6-character passwords. Now, we have to understand, is this a combination question or a permutation question? So if you think about it, let's say my password is XYZ, right? For example. Now, if I enter YXZ, it would not work because the order does matter for a password. Now, because of that, it will be a permutation question. Whenever order matters, it will be a permutation question. Now, no character may be used more than once, so no repetition. Part 1. We have to find the number of different passwords that can be chosen if there is no restriction. So pretty easy. So we have two ways of doing the question. First way is we have 8 available characters. We know it is a permutation. We need 6, that will be 8p6. That is one of the ways. That will be 20, 160. That is your question part 1. Again, that is one of the ways. Now the other way is also pretty easy. For example, I need to choose 6 words, 6 characters. I will have 1, 2, 3, 4, 5, 6. Now for the first position, I can choose anything. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 options. Let's say I choose 1. For this one, I will have remaining 7 options. Let's say I choose 3. For this one, remaining 6 options. Let's say I choose 5, and so on. 5 options. Let's say I choose 8. 4 options. Let's say I choose 9. And 3 options. Let's say I choose this one. So your answer will be 8 times 7 times 6 times 5 times 4 times 3. That is the other way of doing the question, more logical way. 8 times 7 times 6 times 5 times 4 times 3. That will be 20, 160 as well for your answer. 2 ways to find the same answer. Now for part 2, the password starts with a digit, that is the condition, and finishes also with a digit, that is the other condition. So let me write this down. We have numbers 1, 3, 5, 8, and 9. Now symbols we have the sign, $, and pound sign. So we need to form a 6-character password, so we have to have 6 spaces. 1, 2, 3, 4, 5, 6. Now for the condition to be satisfied, we need to begin with a digit. So for this first position, I will have 1, 2, 3, 4, 5 options. Let's say we choose 1. And for this last option, I will have remaining 4 options. Let's say we choose 3. Okay. Now for this one, you will have remaining 1, 2, 3, 4, 5, 6 options. Let's say we choose 5. Remaining 5 options. Let's say we choose 8. Remaining 4 options. Let's say we choose 9. And then remaining 3 options. Let's say we choose this one. So your answer will be 5 times 6 times 5 times 4 times 3 times 4. That will be 7,200 for the number of passwords that we could form with this condition. Now for part 3, the password starts with the 3 symbols. Again, pretty similar. We have 3 symbols here. This, and this one. And then afterwards we have 1, 3, 5, 8, 9. You want to form a 6-character password, we have to have 6 spaces, right? 1, 2, 3, 4, 5, 6. Now, obviously, 3 passwords starts for this 3 position. For the first one, we can choose anything from these 3. There will be 3 options. Then for this one, there will be 2 options. And then this one, I will have only 1 option remaining. So these are the first 3 positions. Again, this one can be anything. So for this one, we can choose from the remaining 5 options. Let's say we choose 1. Remaining 4 options. Let's say we choose 3. Remaining 3 options. Let's say we choose 5. So your answer will be 3 times 2 times 1 times 5 times 4 times 3. As you can see, step by step, we were able to solve this question, satisfying our conditions. That will be 360 as your answer. That will be part 3 of your question. Now for part B, so here we have a combination question. The number of combinations of 5 objects selected from n, so n, choose 5. It is 6 times the number of combinations from, so n minus 1, 4 objects. Find the value of n. Again, so for this definition, sorry. So for this definition here, we have to use the formula we have. As you can see over here, we can use this one, right? So as you can see, let's write this down. So here we have given that n, choose all, that will be n factorial over the value of n minus r factorial, and that will be r factorial. Now we just have to simplify and see what happens here. For example, n 5, that will be n factorial over n minus 5 factorial, and that will be 5 factorial. But now what is 5 factorial? That is simply 120, so we can write this over 120 n minus 5 this. Now for this side, let's see what happens. We have this one here. Here we have n minus 1, choose 4. By definition, it will be n minus 1 factorial over n minus 1 minus 4 factorial times 4 factorial. By definition, according to this formula. Simplify, that will be 4 factorial will be 24. You will have n minus 1 factorial over the value of, here we have 24, n minus 5 factorial. Now we can try to simplify, obviously, replace back in the main equation. Let's see what happens. So on the left hand side you will have this one, which is n factorial over 120 times n minus 5 factorial is equal to 6. Here we have times, this one will become n minus 1 factorial over 24 n minus 5 factorial. Now simplify for the value of n. So step by step, this will go away. Same and same. Divide by 6, you will have 1 here, and that will become 4. Now divide by 4 on both sides, that will become 1, and this will become 30. So right now you will have n factorial over 30 is equal to the value of n minus 1 factorial. So let's see how can we simplify this. So we can send this here and this here. So let's continue here as well. You will have n over this one is equal to 30. So what is the definition of this? So let's think. For example, we know that let's say we know 2 factorial is what it is. 2 times 1. What is 3 factorial? It is 3 times 2 times 1, right? Now what is 4 factorial? It is 4 times 3 times 2 times 1. But we also observe we can rewrite this as 4 times, what is 3 times 2 times 1? It is 3 factorial. So this can also be written as this. Now where I'm going with this, for example, I do understand that n factorial can also be n times n minus 1 factorial. So from here you will have, on top you will have n times n minus 1 factorial divided by n minus 1 factorial, that will be 30. So this and this will cancel out. So finally n will be the value of 30. And that is part B of your question. That is your question number 7. Okay, so let's move on to question number 8. The variables x and y are such that y equal to ax power b. Now where a and b are constants to be found. Okay. Now when log of y is against log of x, okay, this is a linear log question. A straight line graph passing through the points. These are the passing points obtained. We have to find the value of a and b. So step by step, we know we have y is equal to ax power b. Now to get log y and log s, we have to apply log on both sides. Makes sense, right? So log y log ax power b. Now obviously we can simplify on the right hand side. That will become log a plus log of xb. That will be log of y, that will be b log of x plus log of a. So now we can compare to an equation of a straight line. For example, whenever we have y against x, it is simply y equal to mx plus c. Now this one is your gradient, this one is your y value, this is your y-intercept according to this equation. So simply we realize that the gradient m is b and c will be your y-intercept, which is log of a. So we can find the value of a and b by using the values. For example, here we have the passing points we can find the gradients pretty easily. This is x1, y1, x2, and y2. How do you find the gradients? That will be y2 minus y1 over x2 minus x1. That will be the formula we use to find the gradient of a straight line. Minus 0.61, that should be 0.8. So m is found to be 0.8, and hence b will be 0.8 as well for the value of the gradient. Now let's find the value of a. Okay, so to find the value of a, we can use the passing point, obviously, right? This point. Let's use this point. We have 0.61 and 0.57. Again, because we have log y against log x, we understand that that will be log x and that will be log y. Replace back in your equation, you will have 0.57 is equal to, b is equal to 0.8, log x is 0.61 plus log of a. Right, now we have to solve for this value. So log of a will be what? 0.57 minus 0.8 times 0.61, and that will be 0.082. So a will be 10 power 0.082. That will be 1.2078, 1.21, correct to 3SF. That is your value of a. Okay, so let's move on to part B of your question. Use the values of a and b to find the value of y when x is 3. So now right now we know we have log of y is equal to b is 0.8, log of x, log of a is 0.082. This is our equation right now. So we have to find the value of y when x is 3. Replace log of y, that will be what? Well, I think we could do better. We could actually simplify. Oh, it's okay, same thing. We can put in here. We can also put here as well. No big deal. That will be 0.8, and that will be log of x will be 3 plus 0.082. So 0.8 log of 3 plus 0.082, that will be 0.463697. That will be log of y. So y will be 10 power 0.464. Let's see what happens. That will be 2.91. Okay, that will be your value of y when x is 3. Now we have to find the value of x when y is 3. So replace back in the same equation. Let's see what happens. So you will have log of 3. That will be 0.8 log of x plus 0.082. So send this over here. You will have log of 3 minus 0.082 divided by 0.8. That will be log of x. So let's see, what do we have? Log of 3 minus 0.082 divided by 0.8, that will be log of x 0.4939. X will be 10 power 0.4939. That will be 3.118. So your answer correct to 3SF will be 3.12. 3SF. And that will be your question number 8. Now let's move on to question number 9. The first three terms of an AP is given to you by -4, 8, and 20. We understand the first term A will be -4, and here we must have a common difference. As you can see, we have to be 12, plus 12. So D will be the common difference, will be plus 12. Now, find the smallest value or number of terms, which is the value of n, for which the sum of the AP is more than this. So the sum of the n term have to be more than 2000. Now we know that the sum of n term is given to you by half of n times 2a plus n minus 1 times d. Replace back in the equation right here. You have half, and we don't know. 2 times a will be -8. 12 times n minus 1. More than 2000. So let's see how can we solve this. So So first thing first, we can divide by, we can simplify here. Divide by 2, that will become minus 4 and 6. You have n here, minus 4 plus 6n minus 6, more than 2000. Now step by step, n is n here, that will be 6n minus 10, more than 2000. That will be 6n squared minus 10n minus 2000. Now we can divide by 2 because everyone is even. Let's see what happens. You will have 3n squared minus 5n minus 1000, more than 0. Now let's try to solve this. What can we do now? So obviously, as we have seen before in quadratics, the way we solve this, we must first find the critical values. So we have 3n squared minus 5n minus this. We equate that to 0. Now, what is 1000? Let's say divide by 40. That'll be 25. Not good. 1000 divide by 20. Let's say divide by 20. That'll be 50. Not good at all. So let's use our formula here. I just don't know. I guess I just can't think of anything right now. So n will be minus b will be 5 plus minus root of b squared minus 4 times a times c. That'll be 12 over 25. Divided by 2a will be 6. So 5 plus root of answer divided by 6 will be 19.1, or n could be 5 minus root of 12 over 25 divided by 6 minus 1 point, so 17.4, sorry. So what we understand here is that the value of n, that will be 0. Obviously we have to use the graph. It is positive here, that will be in shape of this, as we have seen before. Here the first value is minus 17.4 and this will be 19.1. So as you can see, it has to be above, have to be this part and this part, right? So n can be less than 17.4 or n can be more than 19.1. So the idea is that we cannot use n as negative. It is the number of terms, so that will not be possible. So we can only use this. So n have to be more than 19.1. Now given that n is a number of terms, it will have to be an integer value. So what is the integer after this? That will be obviously 20. So n will have to be 20. So that is your question 9.8. Now let's move on. So the 7th and the 9th term of a GP, so here we have a GP, is given to you by this. Again, this is the 7th and the 9th term. So we know that the nth term is ARn power minus 1. So from here we can write the 7th term AR6, that will be 27, and the 9th term, that will be AR8, that will be 243. So here we have two equations. This is equation number 1, equation number 2. So let's solve for the value of r. So we can take t of 9. So t of 9 divided by t of 7, you will have on one side ar power 8 divided by ar power 6, 243 divided by 27. This will cancel out. You will have ar power 2. 243 divided by 27, that should be 9. Obviously r will have to be root of 9, and that should be the value of 3. Right, this is the common ratio for this one. Now this is part 1. Again, here we have, it is a positive value, so have we positive 3. Now for part 2, we have to find the 30th term, giving you an answer in the power of 3, as a power of 3. So 30th term will be AR power 29. That makes sense. Will be n minus 1. Now what is the value of a? We have still to find this. So a will be replaced back in your formula here. A times r power 6, so 3 power 6. That will be 27. So a will be what? 27 divided by 3 power 6. That will be 1 over 27. That will be 1 over 27 times the value of r power 9, so 3 power 29, sorry. So simplify. 3 power 29. So what is 27? 27 is 3 power 3. That will be 3 power 29 minus 3. That should be 3 power 26 as your answer, as required as a power of 3. That will be part 2 of your question. Now let's move on to part C. Explain why GP. The GP, 1, this and this, for the values between this. As you can see, this is what? This is usually, pi is minus 180 divided by 2 will be minus 90, and 90 degrees, for example, where theta is in radians, has a sum to infinity. So if you observe, the first term is A. What is the common ratio for a GP? We understand that have to be A times R. R is equal to, as you can see, R has to be sine theta, right? Because you can see that A is your first term 1, but the second term is A, R is sine theta, which means R have to be sine theta. This is R. Now we understand we have what? For example, if you look at your list of formula here, you will realize that there's a condition. We can only have sum to infinity when this is less than 1, right? When the common ratio have to be less than 1. So that's the main idea here. So let's write this down. So we know that GP has sum to infinity when the modulus of R has to be less than 1. So replace, you have modulus of R sine of theta less than 1. Now obviously the way we can write this will be sine of theta can be less than 1 or less than, here we have between this one. Because we know have to know how to break this down. If that makes sense, right? Sorry for this explanation. Now what else do we need to do? So we need to find the value of theta. You can see theta. How do you find theta? Obviously we have to make theta become subject. That will become sine inverse, right? Now what is that? Sine inverse of 1, that is 90 degrees. So you will have theta have to be 90 degrees here, and here will have to be minus 90 degrees because of the minus sign. Now we understand that 90 degrees is simply pi over 2. That will be theta pi over 2 minus pi over 2. That will be your value of theta. So for this value, you can see we have this, and hence we prove that it has a sum to infinity. So the main thing is we have to begin with this and then arrive at this, so we can confirm that for this we have a sum to infinity. Again, this is something given to you in your list as well. This is how you know where to begin to formulate your answer, and that will be your question number 9. Now let's move on to question number 10. So here we have to solve the equation, this one, for the value of alpha between minus pi and pi. So step by step. So what is cosec? As you can know, cosec alpha have to be 1 over sine. What is sec? It is 1 over cos. We can replace. Let's see what happens. You will have sine this times 1 over sine square alpha plus cos alpha times 1 over cos square alpha have to be 0. This and this will cancel out, obviously. Have 1 over sine alpha plus 1 over cos alpha. Now what we can do here is we can definitely we can multiply by some values. For example, let's multiply everywhere by cos, right? What you will have cos alpha over sine alpha, and here you will have plus cos over cos will be just 1. From here you will have what else you will have? So I think it's okay, but let's see, it's not easier, so let me do something else. Because instead of multiplying by cos, we can multiply by sine. It will be much easier. Let's multiply by sine because it will be much easier if you observe this, because this is not bad either, but you will just take a few more steps. But let's continue with multiplying by sine. You will have sine alpha over sine alpha and plus sine alpha over cos alpha. The reason why I'm multiplying by sine is because I want to get this one. What is sine over cos? It will be tan. That's why I want to do this. You have 1 here plus tan alpha have to be 0. So tan alpha have to be minus 1. Now we understand when tan is negative, it will be in the second quadrant and the fourth quadrant, right? Obviously this will be the value of, that will be pi minus theta. This will be 2 pi minus theta. Again, theta is not your answer yet. Here we have to find alpha, but theta will be tan inverse of the positive value of 1. That will be pi by 4. Let's check. Tan of 1, tan inverse of 1, that will be 45 degrees, which is pi by 4. Now, step by step, let's find the value of alpha. Alpha will be pi minus pi by 4, or it could be 2 pi minus pi by 4. That will be what? That will be 3 pi by 4, or it could be, so here we have 2 minus 1 over 4, that will be 7 pi by 4. Okay, so step by step, as you can see, the value of alpha have to lie between the value of minus pi and pi. So there's a reason why they gave you this side. We have to see if you have any values on this side. How do you find this? We have to try to minus. Let's try to minus 2 pi here and 2 pi. Let's see what happens. So 3 over 4 minus 2 pi minus 2, that will be minus 1 over 4. That is simply, if you want to expand, so 1, let's expand this fraction. That will be 1 times 4 is 4 plus 1 is 5. That will be minus 5 over 4. So here we have minus 5 over 4 this, or it can be 7 over 4 minus 2. That should be minus 1 over 4 this. As you can see, this will be outside. We don't need this one, but this will be okay, right? Because it will be in this side. So in the end, you will have two values for alpha. Alpha will be minus 1 over 4 pi and then 3 pi over 4. And that is your question 10 part A. Now let's move on to part B of your question. We have to show the left hand side is equal to the right hand side. So step by step, first thing first, we see we have two fractions. The base are different. We have to make them become the same. We have to multiply them by each other. That will be cos theta 1 minus sine theta. Then we have to cross multiply. You will have cos square theta plus 1 minus sine theta square. Simplify. You will have cos square theta plus 1 plus, so here we have minus actually, that will be minus 2 sine theta plus sine square theta over the value of cos theta minus sine theta, and here we have cos theta. But I don't think I will need to expand this. I think I will need to use this one because as you can see, we don't really have a base here. Yeah, I think it will cancel out. But let me check what happens. So at first here we have this. What is cos square theta plus sine square theta? It is 1. 1 plus 1 is 2. So 2 minus 2 sine theta. So let me go back to this one. You will have cos theta, that is 1 minus sine theta. And that will be factorized to 1 minus sine theta over cos theta 1 minus sine theta. This and this will cancel out. You will have 2 divided by cos theta, and that will be 2 sec theta. That is part 1 of your answer. Now for part 2, let's see. Hence means we have to use the value from the top that we have got, which is 2 sec theta, to find the value of sigma. So let's see how can we solve this. So here we have this side is the only difference is we have the angle here on top, it is theta, and here we have this. So pretty easy. It seems that this one will become 2 sec 3 this, and that will be 4, which means sec 3 this will be 2. But we also know that sec is 1 over cos, right? So that will be cos 3 this, that will be half. Now because cos is positive, it will be in the first quadrant and in the fourth quadrant. This will be simply the value of what? Of, as we have seen before, it will be simply the value of the angle. Here we have 3 this, and this will be 360 minus 3 this. So 3 this will become cos inverse of half, and that will be 60 degrees. Now also according to this one will be 360 minus this will become 300. So 3 this can also be what? Let's see, because we have 3 here, we can try and see what happens, right? So 3, this will become, this is 60, this one, let's add a few more revolutions. So 60 plus 360, that is 420. 300 plus 360, that is 660. Again, the reason why we add 360 is because here we have 3. Usually when we have just this, we don't need to add that. In this case, we have 3 here. Let's see what happens. Let's add a few more revolutions and see where does that go. So here we have this, divided by 3, that should be 20. That should be 100. So 420 divided by 3, that should be 140. And 660 divided by 3, that should be 220. Okay, so as you can see, based on the limits, this will be too much, but this and this and this are good. So finally your answer of sigma will be 20, 100, and 140. So if you wouldn't have add 360, you will have missed one value and you will miss on one mark. So you can see it is very important to realize we have 3 revolutions here. We can see and check if we have other answers on the next revolution. Okay, and that will be question number 10. Now let's move on to question number 11. So the normal to the curve y, the point x is this, meets the y-axis at the point P. So find the value of P. So pretty easy. So let's say this is our curve, right? Now this is my point x equal to 2, for example. And we know that the normal to the curve will be a line at 90 degrees this way. It will meet the x-axis, sorry, the y-axis. Let's say this is the y-axis, somewhere over here. At the point P, we have to find this point P. So pretty easy. So this can be done how? So let's see. We must first find the equation of the normal. So to find the equation of the normal, we first have to find the gradient of the normal. But now we understand we can first find the gradient of the tangent, which is simply dy by dx. So here we have y. Let's find dy by dx by using the quotient rule. So dy by dx will be, first thing first, we can write this one. That will be 2x minus 3. Then d by dx of this one will be 1 over x squared plus 2, then multiplied by 2x, minus the top as it is, and multiplied by d by dx of this one, that should be 2. Everything divided by the base square. That will be 2x minus 3 squared. So now we have to simplify, obviously. That will become 4x squared minus 6x over the value of x squared plus 2 minus 2 ln x squared plus 2 over the value of this one. Now this is dx by dy by dx, but we have to find this value when x is 2. Replace, when x is 2, what is that value? That will be what? 4 times 2 squared minus 6 times 2 divided by 2 plus, so 2 squared is 4 plus 2. That will be 2 over 3. That will be 2 over 3 over here, minus 2 ln of, that will be what? That will be 2 squared is 4 plus 2 is 6. And all that divided by what? Divided by 2 times 2 minus 1, that will be just 1. So this doesn't matter here. So we have 2 over 3 minus ln of 36 for the value of dy by dx, which is the gradient of the tangent. Now from here we have to find the gradient of the normal. As we know, gradient of tangent times the gradient of normal have to be minus 1. Just replace. So gradient of this will be minus 1 divided by mt, which is 2. This minus ln of 36. Obviously we can simplify this. For example, we can have a base of 3 here. That will become 2 minus what? That will be over 3. That should be 3 ln of 36. So by doing this, you will have minus 3 on top. That will be 2 minus 3 ln of 36. So this is the gradient of the normal. Now we have x is 2. Let's find the corresponding value of y. So what is y? Replace back here, you have ln of 2 squared is 4 plus 2 is 6. Divided by 2 times 2, this is 1. That'll be ln of 6. So my passing point is 2 and ln of 6. X and y. So we can find the equation of the normal here, pretty easy. That will become y minus ln of 6 over x minus 2 have to be minus 3 over 2 minus 3 ln of 6, 36. That is how I will find the equation of the normal, right? Now again, I can rewrite this as what? Just to simplify this, 3 ln of 36 is the same as 3 ln of 6 power 2, which is the same as 6 ln of 6. Okay, so let's simplify. We have to cross multiply. You have y minus ln of 6 times 2 minus 6 ln of 6 equal to minus 3x plus 6. So what else? We can kind of leave this here, but again, let's simplify. Why not? Because that's not the point. The point is not to find the equation of the normal, is to find the coordinates of the point P. So let's leave this here for now. Why not? So the point P is on the y-axis. So we know that on the y-axis, what happens? On the y-axis, the value of x have to be 0. So let's replace and see what happens. You have y minus ln of 6. 2 minus 6 ln of 6 have to be 0 plus 6. Okay, so we have this for now. Now we have to solve for the value of y. Let's see what happens. So first thing first, you can divide by this one if you want to. So let's simplify. Why not? So here you have y minus ln of 6. That will be 6 divided by 2 minus 6 ln 6. Right. From here you can have y have to be 6 over 2 minus 6 ln 6 plus ln 6. That is your value of y. So the point P will be simply 0 and then 6 over 2 minus 6 ln 6 plus ln 6. Again, you can simplify if you want to. I just don't have enough space here. Try to simplify and see what happens. But the idea or the concept is the same. We first have to find the equation of the normal, right? And then we have to find the point of intersection on the y-axis. And that will be your question number 11.